Okay, I'd like to go over a few more scales. The first of the scales I'd like to show you here are the A and B scales. Well, first of all, let's examine the A and B scales, see what they are. The A and B scales are identical to the C and D scale, except that if you take the C and D scale and shrink it down to half its size, that'll give you what's on the A and B scale. Right, it's the same kind of pattern, a logarithmic scale, just shrunk down to half of what's down here. So it runs from 1, primary numbers 2, 3, 4, 5, 6, 7, 8, 9, 10. And we look again, here's the same thing repeated. Primary numbers 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Well, a couple of things that's good for. For one thing, you don't have that problem of the slide running off the scale again, right? If we want to multiply something like 5 times 6, I'll go ahead and line up the index here with the 5. Oh, the 6 ends up somewhere way off the scale here. If we use the A and B scale, right, if we don't need a lot of accuracy, we can use a condensed scale like that. Line up this index with that 5, and go ahead down here and look for 6, and right above it is 30. So that's one use for the A and B scale. What's even more impressive than that is that when you shrink a scale like that down to half its size and repeat it the way they did here, there's a relationship in between the two scales, that of squaring. Well, let's take a look. 2 squared, we know it was 4, and there you go. Take something like 3 squared. Well, line that up with the 3 down here, and sure enough, you have 9 there. Something like 1.5 squared. 2.25. And here's your 2. There's your 0.2 and 0.05. So that's how we can use the A and the B scale for squares and likewise square roots, right? If we want to take the square root of 64, and all we have to do is go up here and grab our 64 and read down here. That gives us the, let's see, what's this example? This is 64 right here. Right, and that lines up with 8. And if we want to take the square root of 25, that should line up with 5. Indeed it does. Okay. Next up is the K-scale. What is the K-scale? Just the way we took the C and D scale and shrunk it in half and put them up here. Now what we're going to do is take the C and D scale and shrink it down to only 1/3 of its original size and repeat it 3 times. So this K-scale is a logarithmic scale. It runs from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And from the 10 it goes 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And from there 100, 200, 3, 4, 5, 6, 7, 8, 9, 1,000. And just the way you had the relationship of squaring going from the D to the A scale, if you go from the D to the K scale, you get cubes. So I line up there with the 2, I get 8. Likewise, the cube root of 8 is 2. I can read it in either direction. Right, if I want something like the cube root of 64, go get my 64 right here. Here's 6, there's 4. Read up here, and there's my number 4. And that's how you can use the K-scale. Let's go ahead and flip this slide rule over, and we'll take a look at this other scale up here you may have noticed before, LN. The LN scale isn't quite as versatile as the L scale. You can't read as many numbers off of it because Gauss scale is a base 10 system, a working a base 10 number system, but natural log is base E. So that's why they actually put very explicitly here 0, 0.1, 0.2, 0.3. And if you look a little down the line, you have 1, 1.1, 1.2, 1.3. The scale is only good for certain values. Like if we want to take the natural log of 3, I go ahead and line that up with 3 right there. I look up here, and I get something right around 1.1. I want to take the natural log of 4. And I get about 1.39, it looks like right there. About 1.39. And likewise, if I want e raised to some power, e raised to the first power here is 2.7. E squared. Oh, here's my 2. Read down here, 7.4. What's a little bit more accurate and slightly more versatile are these double log scales. You won't find the natural log scale on too many slide rules. This is just one particular slide rule that had it. The double log scales are a lot more common though. The reason they call them double log scales, well, you had to take a logarithm going from here to here. Likewise, you have to take a logarithm going from here to here. Notice I have my E right there. That's marking 2.71828. And that lines up with 1. So the natural log of 2.7 is 1. Something like the natural log of 20, which I couldn't read off this scale up here. Natural log of 20 I find is 3.